Okay, so let's look at the concept. Here we're looking at a curve, even though none of it's curved, that has the phase transitions over time. And in a heating curve, what you're doing is you're adding heat over time and looking at the different temperatures. Whereas in a cooling curve, what you're doing is you're looking at the heat being taken away or cold being added, however you want to look at it. Okay? So on the flat parts, we have a mixture of both solid and liquid, or gas and liquid. Okay, it's a mixture is the key point there. Whereas at the slanted portions of these curves, it's just one phase. It's just going to be liquid, solid, or gas. Do you understand
The
that?
slanted part is the phase, and that's what has liquid, solid, and gas in it. And it's like middle, top.
Just
Yeah,
one,
it's like
just one of
the
them.
middle one is like supposed to be like liquid, and the top is supposed to be like gas in the bottom.
Exactly.
Yeah.
Gas only. Okay, but the one in between liquid and gas right here, the one I'm pointing to with
That's a
the
mix.
arrow, is going to be gas
mix.
and liquid. Okay, good. All right, so that's going to occur. The flat portion is going to be the boiling point and the melting point. Okay, and then here is condensation freezing points, and they don't call it melting; they call it fusion. Okay, keep that in mind. And we're still going to be using the same enthalpy formulas that we have for the change in temperature ones for the slanted regions. Mass times specific heat
And then
times delta T. But for the flat regions, go ahead.
isn't it change in enthalpy times the moles?
Yes, and this change in enthalpy is a constant, okay? Something you're going to look up on a table. So all this stuff is going to be using 1 mole of whatever we're looking at. Here is, for instance, water. Okay. Here are the delta H's of fusion, for instance. That's when ice melts into water. Okay. Then vaporization is liquid to steam, like liquid water. And sublimation is when we go ice directly into vapor. And we're going to have these change in enthalpies for those flat portions. These are the flat portions that I'm dealing with here. And this is a heating curve.
And like we have to memorize those.
No, that should be
constants?
given to you. These should be given to
Okay.
you.
And if it's like if it's the cooling curve, that means it turns negative, right? That's the only difference, right?
Very good question, and you're absolutely right. I was about to go over that next. Good question. All right, so as you just said, you just take the negative for the reverse, but that's basically it. So I think we should just try a problem, okay?